Hi, everyone. Thank you so much for joining my talk. I'm super excited to be participating in OpenTelemetry Day this year. We've only got 20 minutes. It's going to be a quick one, so let's go ahead and dive right in. So this is planning for observability. We're going to talk about the general strategic, some of the tools-based considerations in how we build our services and our teams to create more observable applications. My name is Noshnika. Nika is fine if you're having trouble pronouncing Noshnika. I am a developer advocate for New Relic. I specialize in serverless and in cloud engineering, though I do work with some other tools and I work with containerization quite a bit as well. I tweet at Serverless Mom, or I tweet about DevOps at Serverless Mom, so come check me out there. And also, I'm up on Twitch at least twice a week, streaming some development content, making services, and sometimes other fun stuff like we do some programmable music and some other pieces. Okay, so let's hop into it. So let's ask the first question, which is something that I actually get to talk about all the time, which is what is observability? And there can be a little bit of confusion here. Sometimes people think, well, observability is just it's some new tool set on top of monitoring or logging, or that it's like a branded thing, like it's like a marketing term. And I mean, it gets used for marketing, but I think that it does have a pretty clear definition. In my mind, I think observability as being the first half, when we talk about mean time to resolution, that observability is that first half. It is how quickly we're able to understand a problem and know what needs to be done next. I see that my video is blocking this cool escapement diagram that I wanted to show, so take a look at it there, but I'll put my video back in the corner. So with observability, the question is, once we know that we have a problem, which is usually not really an observability problem, usually we get some alert, some knowledge that we have a problem, then how long does it take us to understand it? Now, there can be some kind of notable exceptions to this. For example, if you have a service, you have a server that's running out of memory all the time. Maybe it's leaking memory. Maybe you never really understand why it's leaking memory. It does it infrequently enough that you can just go ahead and restart the server, and then things roll on just fine. Well, in that case, we did solve the problem without understanding it. But we would generally consider, right, that wasn't a very great experience. Even in that case, we'd say, okay, we need to add observability here. So observability is a little more than any specific tool or technology. And why is observability important? Observability kind of is very often is the thing that stresses people out, stresses engineers out the most, right? This is a quote from Patrick Stager, who works with serverless quite a bit. And, was talking about serverless. He says, I can scale serverless as big as you like, but a random 500 error I can't diagnose, that's what gives me hives. And he said this to me, it really stuck with me on a podcast, because it really is very often our ability to understand how our complex system works, that stresses out a lot more than maybe implementing new features, maintenance, or controlling costs, or those sort of other questions. In general, when I talk to developers, I find that, developers, engineers, operations people, anybody who's working directly with technology, I find that especially on cloud platforms, observability problems come before complexity and before cost in their sort of hierarchy of what are challenges that they face. And it's not that they're not, it's not like, oh, well, cost is a challenge, and architectural complexity is a challenge, but trying to understand their system frequently or with high clarity is very often something that it's a little harder to know the way to actually solve observability problems, right? So one of the funny corollaries of defining observability this way is that there are, what affects observability is much bigger than just a technology. So one example, I mean, this is quite recognizable, right? This is a Prometheus Grafana dashboard. And, one of the things I always think when I look at these Grafana dashboards is, the very, very high readability, right down to color contrast. And these are all things that have an effect on observability. So That's important because if we're thinking about, hey, how long it takes to understand a problem, then surprising stuff has an effect on that. Again, the readability of dashboards has an effect. The experience of your team has an effect on that. So if your three most senior engineers leave your team suddenly, that is going to mean that your observability just dropped. The information store there is the same, but the ability to look at it and understand it just fell off. I think also as an example, observability is more than a single technology. So one way to think about that is that if you went into your code and you added console log lines at every single line of code to, give the exact state of your system at each line, the amount of information that you'd be storing would go way up, but your observability would go down because it's not just that yes, your log storage bills would get out of control, but also that the ability to go in and look at your logging and find what the actual problem is would have just reduced because the useful information would be buried by a bunch of noise. So coming back to like a random 500 error, let's talk a little bit about what we would consider to be some of the information that we'd like to have when we're getting maybe a 500 error or sort of another change to our configuration. Change our configuration. When we're looking at like one of our endpoints is giving us, sudden, unexpected, super negative results. So here are some of the pieces we might like to see to sort of approach observability on that system. So our front end endpoint is giving us errors. Well, we don't know right where they're coming from. So one thing we'd like to see, right? These are the four pieces that kind of occur to me first, right? I'd like to see error rates on each component, right? Is that just that gateway or whatever it is that's at the endpoint? Is it returning a bunch of errors? Are we seeing errors thrown someplace else? I'd like to see what's the throughput on the furthest back-end component. So what's the throughput on the piece that is standing all the way usually, probably maybe like a database component, and there, a nice readable dashboard would be super useful because seeing if our throughput on the database suddenly dropped up a cliff, we can sort of start to assume, well, it's probably that, requests aren't even reaching there. It's not that the database is returning bad data or returning errors. We'd want to look for changes to permissions and configuration, and then deployment history to our code. And these are all things that help us get that information. And frankly, I am not enough of an expert on just the application instrumentation to talk about that. We're really going to talk about how all of those pieces inside of our stack affect observability because, yeah, OpenTelemetry is great. And we want to talk about how we can engineer the other pieces of our application stack to be just as observable as possible and just as easy to take apart and understand as possible. Okay. So let's talk about picking the right tools to create an observable system. So this is Tom McLaughlin. We were talking on another podcast about the tools for infrastructure as code and the tools for creating templates that define how your code is architected. And there's a lot of great tools out there. And in our case, we're talking again about serverless. So we were thinking about, do you want to use Terraform? Do you want to use serverless framework? Do you want to use, there's dozens, there's Stackery or all great tool sets. What it really came down to is, and here's the quote, if you're just listening to me on a jog today, it's, what tools should you use for infrastructure as code? Yes. And the fact is that much more important than exactly how you template your infrastructure, it's that you want to use something. And, you see too many people who are storing code in one-off repositories, storing config in one-off, storage units, maybe storing some environment variables in like a shared spreadsheet that you want to paste in for each command, or storing deployment commands in like a README somewhere and no place else, and that deployment command contains a bunch of config. So using some kind of infrastructure as code tool is a really key piece. Let's talk about what we get. This is a blueprint from the design of the Alcatraz Lighthouse. And blueprinting is kind of where it's at, right? Infrastructure as code is storing the information about how your infrastructure is going to work in a code repository somewhere. So what we should get from that is we should get a commit history. We should get clear communication of how the infrastructure actually works, because we should be able to actually, define that clearly within a config file. And that middle one is a bigger effect than you might think. You might really think if you're going into a console and configuring your platform, you feel like, I totally understand this. But when you're asked to put it into a template file or put it into a config file, that really can make you realize that there's some vagaries there, or there's some points that you had not clearly thought about that you have to go and explicitly configure. And then the last, obviously, is well-documented requirements, that you make it easier for someone to browse through and say, hey, what does this service actually require to run? Let's talk about another piece of tooling. So infrastructure as code, again, I'm very tooling agnostic on that one. And here too, I think that we are pretty agnostic. I'm completely agnostic. I'm not recommending a specific tool. I just want to think about this a little bit, right? That a little bit of a pre-structure can go a long way. Thinking about structured logging. In my little attempt to illustrate structure, I've done my own crude version of a tiling. And if these are familiar to you, hit me up on Twitter, and we'll talk a little bit about forbidden crystal symmetries like this one that I really like to talk about. But anywho, so structured logging, right, is the concept that rather than just having like single like plain text anecdotes in our logging for each event, we try to log with some kind of object structure that makes it easier to go back and query in later. Now, again, there's tons of toolkits to do this. There's tons of services to add magical structured logging, and those all can be totally reasonable. But structured logging is something that you can do right from the hobbyist level, right when you're first going in and saying, hey, I just want to log that I handled this event correctly. Like, just think about creating an object at the start of that run that says, okay, what is the status of this job, and just changes the set of object parameters rather than just logging single plain text lines. And the first few times you do it, and the times that I teach it to people who are in boot camps and whatnot, it sort of feels like, okay, why are we doing this? But let me tell you, the first time that you start querying these objects and looking at them and being able to sort through them to figure out what's going on with your system, such a relief, right? This is just sort of a random illustration of that kind of structure. You can read Yan Kui about this, who wrote very movingly about this. Your logging must be structured. But yeah, super useful to do and worth your time. So let's talk about alerting strategy. Now, I had previously mentioned that observability is often not necessarily alerting, right? Sometimes the alert or the time that we're measuring observability is often sort of after we know we have a problem. But alerting is part of the observability map, because we have to hopefully get alerts that are useful to us and happen at the right times. That maybe we're not always acting on every alert, but it's that alerting information that tells us a little bit, the first clue about what's going on. So a couple of points that I think are worth noting are low and high threshold alerts. So low and high thresholds are especially useful for invocation counts, and also really useful if you have some way to measure, like if you're using a virtualized environment, or even if you're using like a function as a service environment. If you can get some kind of cost alerting, both high and low, this can be incredibly useful for when you do have an incident. You can look back at these alerts and get some kind of reasonable expectation of what's going on. And the reason for that is this truism, right? That having 10 times the number of page views you had yesterday is a problem, but having 0 times is also a problem. So having low threshold alerts can often tell you as much as having high threshold alerts, and especially when we go back to sort of a random 500 error from the service, that can often be really illuminated by the fact that maybe our database or maybe one of our queues suddenly has nothing in it, which means that we sort of at least know, it's something to the left of that is what we're investigating. Just as a little side note here, I'm realizing as I go through this, I'm talking about observability, and I'm often sort of talking about like an event, right? Like we're up in the middle of the night where we're looking at an event. But as we all know from working with telemetry, it is not necessarily about that. It's very often not about that. Observability work very often means that we just understand our system better. Whether or not we're running around in a crisis, we might just be trying to improve performance or just answer basic questions about, hey, why does this new thing, why is our billing changing? Why are we delivering this performance to the user? That a better observability means that we can answer those questions better and explore growth in a more cogent way. I don't have a slide about that, but it just occurred to me that I sort of had to say that one. So let's talk about creating and encouraging observability by the way that we create our team. Okay, this is a classic joke, but I'll still say it, right? We've all seen these listings, right? DevOps Ninja, right? You need to have 5 years of serverless experience, you need 10 years of Kubernetes experience, then you got to relocate to Greenland. And you always wonder, you see these things, you always wonder who on earth, who wrote this and who's applying, right? These are all for those not in on the joke, right? These are all requirements that you know something for significantly longer than it has existed. But even outside that joke, the fact is that, we do see a lot of people who really are struggling to have the competence that they need on their team, right? Maybe they have a highly containerized architecture and they say, well, to really get the knowledge that we need, we're going to have to hire some real pros here to get that. And the reality is, even if you turn down these time requirements a little bit, it would still be looking for someone impossible because the fact is that these are very hot technologies. They don't have a ton of people who are super good with them yet. And so we just are in the situation that a lot of this, there just aren't the people available. You can't hire experts to do this sort of work because they're already doing great jobs. They're already busy. And so I think that's really important because I really see in this area that great teams aren't hired. You're going to have to grow them. And this is a critical piece of observability because, first of all, of course, the better your team skills, the better they're going to do at understanding their alerts and their other instrumentation messages. But also, it is by actively pursuing the growth of skills by everybody on your team that you're going to create the deep knowledge of your system that is going to mean that when they're looking at warning signs, they're looking at log messages, everybody on your team is going to be prepared to handle that. So first of all, you want to look for the seeds that you need for that, which can be both, of course, people who have great experience and want to apply that in this new realm, in the DevOps realm. Also, you want to look for seeds of people who maybe are just starting out, but have a real interest in fully understanding how a stack works and going all the way from looking at the code that we're deploying to how it's really performing in the real world for users. Those can be really, really key people to grow your team around. And then development, resources, soil, that's the big one, right? Whether it's, a Cloud Guru memberships or, certification training or, some time to study independently and pursue new technologies. Very often it means giving people the tools they need to deploy to test frequently. And so letting them explore and try out new tools. So those are really key pieces to let that team grow. And then the last is sunlight. The last is good communication between your team. And actually, I think that things like infrastructure as code are a key part of that honest communication, that you want to let people communicate in a real way about how their services are interacting. And I think that if you give people these growth opportunities, not only will you grow great candidates, but you'll keep some of your best people. Because the reality is that some of the best people, the reason that they stick around someplace is because it's where their skills are growing. Okay, so we're coming up on time. I, again, am Noshnika. You can find me over on the New Relic blog pretty frequently. If you want to talk to me every day, go hit me up on my DMs are open at Serverless Mom, or you can come see me on Twitch at Noshnika. If you have any questions, do feel free to chat them at the team, and we will try to get back to you right away. They'll probably come grab me to work in the booth. And thank you so much for coming out. Hope you have a great conference.